Hey all, welcome to another session with me, Varun at OdinSchool. And in this session, let us understand what is deep learning with TensorFlow using a mini project. Now, I'm pretty sure by now you all must have understood why should we learn TensorFlow, how would learning TensorFlow give you an edge over others, and how would this library actually enhance your skill. Now that is where we come into picture. Now we at OdinSchool, we are a technology upskilling platform and we would help you continuously acquire new skills. And I'm your trainer and I've been with you over the last 2 to 3 videos in trying to explain what is TensorFlow. And I have an experience of 7 years working as a developer and a trainer. And over these years, I've gained knowledge and I worked on different languages like HTML, CSS3, JavaScript, R, Python, machine learning, and etc. and a lot of other minor languages. And the agenda of this session would be to understand a simple neural network using NumPy. We wouldn't be going very complex right now, but we would be working on a hands-on model that you all can try at your home, that you all can try at your system without any deep knowledge of deep learning neural networks. You just have to understand what is it that I'm trying to show you or what is it that I'm trying to tell you over here, and I'm pretty sure you would be able to practice this at your home. So we would be trying to understand a simple neural network using the NumPy library. I'm pretty sure we all know what is this library NumPy used for. It's a very famous library for any mathematical operations in Python. All right. Then we would be understanding different libraries and we would be working on a mini project using the above mentioned. So we would be using NumPy as a library to construct a small neural network model, and we would be comparing it to how the output prediction and input prediction would vary or would match for us to decide on a model. And based on this, we would be having different epoch values to calculate and to come up with a comparison and to ensure that the error value is as least as possible. Now, guys, whenever you're working on any model, it could be a machine learning model, or it could be a deep learning model, or it could be any model. The goal of any model is to ensure that you have minimum or the least error. Now, what is error? Error is basically the difference between your actual and predicted values. And the goal of machine learning or deep learning or neural networks or different variants of neural networks is to work rigorously, even though it becomes a bit complex in the process, to work rigorously and to ensure that this error rate is as minimum as possible. That is, this difference between the actual values and the predicted values is as minimum as possible. So now in this project, let us understand, let us probably work on a very small project where I've tried to create a small set of values where I'm taking x1, y1, x1, x2, and y to be of three values, and I'm giving a learning rate of 0.01, and I'm taking two different weights of 4 and 7. And now what I'm doing is I am using for epoch in a range of 50 numbers. Now, what do we mean by epoch in technical parlance is very important for us, guys. Now, when we talk about epoch, it is basically a point where the time starts. All right, now you could give a lot of examples to this, like on January 1st at exactly at 12 a.m. is when the epoch starts. Or probably you can also say epoch is an iteration, but epoch and iteration are technically different. Iteration is one-time processing for forward and backward for a batch of data set. But then epoch is once all images, or once all your data is processed individually one time for forward and then again backward to the network, then it is one epoch. Okay, now why is epoch used? Epoch is used to serve as the reference point as to from which time it is measured. Time measurement units are counted from epochs. So this is how you could say epoch is useful. So now here you can see what I'm doing is I'm taking for epoch in range of 50 numbers and I'm giving the prediction value with an equation that is xa plus yb. In simple ways, you can say it as x1a plus x2b, wherein x1 and a are product of each other and x2 and b are product of each other. Now values of x1 and x2 would be taken from the top, wherein we have mentioned what they are, and I would be entering and this logic or this value here would be stored into y prediction. Likewise, I am also creating an error value wherein I am taking my values of y, which is 32, minus this value that would be calculated exponential 2. Now that is something that my error would be coming up for a calculation with. And now I'm using partial differentiation of error with respect to the weights A and B. So here you can see I've been using two weights with two different random numbers. One is weight of 4 and the other one has a weight of 7. Now the goal at the end would be to understand what best values of weights should I use to ensure that I have an exact prediction of 32, which is my input. So my input, which is my actual, and my predicted, which is my output, both of them are 32, which means that the error is 0. That is only when it can achieve an accuracy of 100%. So now we are trying to see, or we are trying to achieve this accuracy of 100% using gradient descent after we have partially differentiated them, or we have partially, we are done with the partial differentiation of error with respect to weights A and B. We would now be applying gradient descent formula to update the weight values. So here you can see I have weight of A and weight of B, wherein the weight of A is subtracted from the learning rate into the product of differentiation of weight of A. The same is happening with weight of B. So here you can see B is being subtracted. The actual weight of B is being subtracted from the learning rate into the learning rate product of the differentiation into weight of B. Now what I'm doing is I'm directly printing these values, guys. Here you can see I'm printing the value of A with the field A, and I'm also printing the value of B with the field B. And not to forget, error is also to be considered. Whenever you're calculating any value, as I said, error happens to be the most important parameter. So here you can see I'm also calculating the error. The error is, and I have given the field error. And error is a formula that I am considering here. As you can see, error is y minus y predicted exponential 2. So now let us go ahead and see how it would bring about a difference. So here when I am taking the value of epoch for a range of 50, you can see that initially my value of A is 3.5 and value of B is 5.9, wherein the error is 121. The error is pretty huge. Just in the next instance, you can see that the values have reduced by 0.2 here and probably 0.5 here, and you see that the error has fallen almost 5 times. So this is how your values would also differ based on very minute changes of weights. Weights make huge difference to how your data set or to how your values of output could react. So here I am calculating different values of weight A and weight B with their errors respectively. Now that I have calculated them, you can see that my error is continuously decreasing, while or you could say, with the decrease of my error, I also see that there is a steady decrease in the value of A and B as well. And at the end, when I would want to check what are my two weights, I see that my two weights are 3.24 and 5.10. So what would this mean? This would mean that with these weights, with these weights in a value of x1, which is 2, and x2, which is value of 5, I would be having an output value of 32. Now, I would just request you to note down these values of 3.24 and 5.10 in a piece of pen and paper. What you could do is we could change this value to 35 and we could execute this code once again. Now, when I do this, you would see that the values would now change. This is 3.2 and this is 5.1. You see now this is 3.4 and this is 5.6 and the value is adjusted to 35. So it means that with whenever I take a weight of A is equal to 3.4 and B is equal to 5.6 or 5.62, I would be having an adjusted weight of 30. I would be having an equation which would yield an output of Y which is equal to 35. So now you can again see that my input which is Y is equal to 35 and my output which is a combination of that formula, both of them have a value of 35, which means that my actual which is given through the data set as an input and the predicted which I have calculated after epochs or which my system has calculated for different error values, both of them are now the same, which means I have an accuracy of 100%. And hence I can say that this model or this kind of a neural network would best suit such requirements. So I really hope you have understood how to work on a very small model of neural network. So here, let me give you a small recap of what we have done. Here, I have considered three libraries, that is NumPy, Pandas, and Matplotlib. And then I have taken three variables. The first variable being x1, the second variable being x2, and the third variable being x3 or y. Now, the agenda is for me to understand at what different weights of A and B would I be having an output which is matching the input of 35. And in order to do that, I am calculating for different epochs, and you can see that for different epochs I have different error values. And also the most important thing to note here is the error values continuously decrease, and they would be decreased till the value of your error is almost 0 or 0 in most of the cases if possible. And if your error value is 0, it directly means that your input and your output are the same, which means that they have an accuracy of 100%. And how are we getting that? In order to do that, I am just using a differentiation here. I'm differentiating them or I'm differentiating my error with respect to A and with respect to B for x1 and x2. So this is a value of x1, this is my value of x2, and this is an error value that I have come up with at the top. Now after this, I'm using gradient descent formula to update the weight values. So here you can see my weight value, which is A and B, are now being updated because they've been removed or they've been reduced of the learning rate, or they've been reduced of the product of learning rate and the differentiation, the partial differentiation of A and B. After which I would now be printing values, and you would see that the values from here would be getting reduced for different epochs, and for different epochs I would be having the value of A, B and error reduced to the best possibilities. After which I would be printing values of A and B, and here you can see or you can match that I would be having a value of 3.4 or 3.44, which is exactly there and here. Then for the value of B, I would be having a value of 5.620, which is exactly as here. Now, when I check or when I substitute the value of these weights into my equation, that is x1a plus x2b, you can see or you would now be able to understand how these epochs have been able to create an equation with the best possible values that you could give into your system, wherein the values are now matching. So here you can see you have an output prediction of 35, wherein your input actual is also 35. So I hope you have understood how to work on a very simple project, and here we have seen how epoch values are calculated, and we have also seen how to come up with a comparison and also to ensure that the error value is as least as possible. Now here the most important thing that I would want you to remember is, in order to keep the error value least, there is nothing implicit that we have to do. The system would do it explicitly. I mean, you don't have to mention anything explicitly. You don't have to go way out of the box to do anything. The moment you set up an epoch and the moment you give the return condition, your system would be able to take care of what is required and what is not. So I hope you have understood how to create a simple neural network using NumPy. And in this process, I also hope you have understood how to use very simple libraries like NumPy, Matplotlib, and Pandas to work on a complex project like neural networks, or to work on a complex or a project which is generally not done in machine learning, at least using the concept of epochs and all, for a very simple, basic deep learning project. And through this, I hope you also have understood how we work on a mini project. Now, I would really like to thank each and every one of you for your patience. Do not forget to hit the like button and subscribe if you feel that you understood and if you feel that this video has been of any help to you. And also, do share this video to all your friends, or to as many friends as possible, as the more you share, the more you care. Thanks a lot. This is me, Varun, your trainer, signing off. Have a great day and all the very best.